All right, hello. We left it off here where we had this situation that they had given us, where we had two vectors. One of them was of size 3 and the other one was size 4, and they gave us the angle between them, which was 60. So we shifted this vector over there to put it heads with tails, and then we looked at the resultant, and we used the cosine rule, which we have to use whenever we don't have a nice little right angle triangle like that. Whenever we don't have that and the angles are a bit more like this and we want to find out that, then we often have to use that rule, the cosine rule. So we used that, and here it is. That's how it looks. And I explained a little bit what that idea was. When you use that whenever you have one side and the second side and the angle in between, and you're interested in this guy. Or maybe you're given this and you're given that, and you're interested in the angle and you're given this guy, and you can use that also. So once we had we used that to find the hypotenuse, which was r, which is this root 37 that we got. And we now wanted this angle here, because we were given this big 60 angle, but we didn't know this small one there. We were asked in the question not only for the magnitude of r, but also for the direction. So we started drawing here the triangle that we had. We had the root 37 and the angle of 120 here, which we worked out using logic, because if this angle here is 60, then this angle there is 60. Since this vector and that vector are both q, they go in the same direction, and this is just a continuation of the same line, then that guy there is got to be 60. And if that's 60, then if this is 180, that's got to be 120. So I was just about to talk about here about the sine rule, or the rule of sines, which you use whenever you have opposite pairs. So here we have one angle and the opposite side, and here we're interested in finding this angle and we have the opposite side. So this triangle is just this one over here, right? It's the same one without all the rest of the mess. So we're interested in finding this angle, and so whenever we're interested in finding angles in the sine, we write the sine on top. So here we have the sine of the angle over the side corresponding opposite is equal to the sine of another angle over the other opposite. And you can use ratios to then manipulate this and find whatever you need. So let's use that to find out what theta is. Let's call this guy A, big A, that's little a, this is little a, that's big A. And then let's call, well, instead of theta, let's call this guy angle big B, and that's little b there. So then in our formula it would look like sine of big A, which is 120, divided by the side A, which is root of 37. That's going to be equal to the ratio of these two, which is sine of the angle B, which is the one I actually want, they asked me for in the question, divided by the side B, which is 4. So we rearrange this, and since we want to leave the sine of B alone, this is what we want to leave alone, then we want to move the 4, and the 4 is dividing, so it goes on to the other side multiplying. Now when I multiply a fraction by a number, I want you to realize that if I multiply 4 by, for example, 1/4, then 4 times 1/4, you just multiply by the number in the top, so then you get 4/4, right? Which is the same as 1. 4 divided by 4 is 1. And it makes sense, right? If I've got quarters of cakes and I have 4 of those quarter cakes, then I've got one whole cake. So hopefully that makes sense. So only the top multiplies by that. And the other way of thinking about it is, normally if you have a fraction like 1/2 and you multiply it by 1/4, then you multiply the top by the top and the bottom by the bottom, right? So then you do 1 times 1 is 1 over 8. 2 times 4 is 8. So 1/2 times 1/4 is 1/8. And if you're dividing, then it's different. If you're dividing, then you might remember the trick. If you're dividing that by 1/4, then you multiply them, but you multiply them crossing. So it's the same as saying 1/2 times 4 over 1. Right? You flip one of them upside down and then you multiply them normally, and then the answer you get is for the same as the division. So that's a small recap on fractions. Hopefully if you've done the work on the Khan Academy, that will be a bit superfluous and not necessary. So bringing the 4 to the other side, since here it's dividing and multiplying by 4 both sides of the equation, we end up with 4 times the sine of 120 divided by the root of 37 is equal to sine of the angle that we want. Let's work out what the left hand side comes out to. It's sine of 120 times 4 divided by the square root of 37. 0.56, so I'm going to write the long decimal because I'm now going to do the inverse sign and I want not to make mistakes with this. 9, 4, 9, so 5, 6, 9, 4, 9, 4, etc. is equal to sine of b. So now if we want b, it's the shift of sine, so the inverse sine of that decimal, whatever that is, and in the calculator I recommend you use the ANDS button, which gives you it's at the bottom right next to the execute or the equals, and it will use the full the full answer when it puts it in there. So the angle then comes out to shift sine of the answer 34.7. Okay, normally you leave answers with 3 significant figures, but with angles you always leave it to 1 decimal place generally. In this case, 3 significant figures and 1 decimal place is the same, but if the angle was 7.2 degrees, then you leave it at 7.2. So there we have it. We have a force which is root of 37 newtons, and perhaps I didn't say newtons, so that was, yeah, here I put it, but I didn't put it on the other one, so that was bad. It's newtons, and you don't need it so much here when you're doing geometry, but anyway, it doesn't hurt. And hopefully that all makes sense. There's not very much new going on in the terms of the actual theory of handling vectors, but it's just a little bit more involved trigonometry. But when you do a few of them, then you'll see that that's okay. In the exam you would very rarely get many of these. You'll get maybe one just to see if you can do the sine rule or the cosine rule, but you don't get many of them because they're very time consuming, and they want to check other things also. So hopefully that's alright. Now let me see how we're doing for time. Okay, we're not doing too badly. We've got like another 7 minutes left, so I'm going to do another example, or at least start and see if we can finish it, of a similar question, and hopefully this will finish sinking in the idea. In this one we have the same situation, right? What example number was that? Well, it was example 1, and so we did 2 down there, and so this is going to be example 3. It's the same type as example 2 really. So that's OY, and this would be OX, and they tell us here that the P is 10 newtons, so 10 newtons is going to go along OX, and the other one is going to be 12 newtons. So if this is P, the other one is 12 newtons, but it's 120 degrees. Okay, so if this is 60, this is 90 degrees here, 90 degrees all the right angle, then 120 is 90 plus another 30, so it's going to be 30 degrees. No, that's more like 45. It's going to be like 30 degrees to the vertical, so somewhere along there. So that they tell us is 30 degrees, or we can look at it as this is this here. This thing here is 120 degrees. This is our vector Q, and it is 12 long, right? So what happens if we add these guys? Let's see. If we add them, it means moving the tail of this guy to the head of the other, right? Or the head of this one to the tail of the other. It's going to do the same result. But let's do it this way first. So if we move Q, so just to remind you what we're doing, we need to find out the resultant of the addition of these two forces on a particle that's here, and see what the resultant is. In other words, if we had two different forces like these two acting on the particle, then we want to find one equivalent force which would act as the combination of both of them. And another way of thinking about it is, if you had two ropes like these and you pulled out with these two strengths of the two ropes, then what direction would it move with, and with what force? And something like that also is a useful way of thinking about it. Let's see. So let's move this guy over there, and that would mean that this is the direction, so it's going to be in a kind of similar direction, like that. It's not very straight, but I don't know if I'm going to be able to make it much straighter. It's not my drawing day today. It's not so easy with this. Okay, so that's the other arrow, and if this is Q, then let's see, what does our resultant look like? Well, resultant is always from the tail of the first one to the head of the second one. So look what we have at the end. We have a triangle that looks like that, where this is our resultant that we want to find out, and we don't know the angle really of this here, but we can work it out by doing some geometry probably. Eventually we need to find that R, but for now we just have to find as many angles as we can. So the angle that we can really find is this one here, because if we continue this line there, and if we know that this angle here is 120 between this one and that one, then this is 120 also, because it's the same angle. So if this is 120 and that whole thing is 180, then this is going to be 180 minus 120, which is 60 degrees. So now we have one angle and this side, which is 10 newtons, and we need another side, and it is this one, which is 12. If that is 12, this guy here is 12, because it's the same vector with the same side, and it's going to be 12. So like in the previous example, we have one side, two sides, and the angle in between. So that should scream at you cosine rule. So let's do it without much contemplation. B squared plus C squared minus 2BC cos A. Now we're running a little bit short on time, but let's see if we can finish this one, and then we do the angle in the next one. So let's find R. So if A squared is R, then let's do it in the color corresponding to the resultant, and that's the R squared. B squared and C squared would be these two guys, so that would be B squared is 10 squared is 100, plus C squared is 12 squared is 144, minus 2BC, so that's 12 times 10 is 120, times 2 is 240, times the cos of the angle in the middle, which is 60. And therefore R would equal 344 minus 240 times cos 60, and cos 60, I think it's, yeah, it's a half, times 240 is 120. So in other words, R squared is equal to 244 minus 120. So R is equal to the square root of 124, I think. I mean, that makes sense. And the square root of 124 comes out to be 11.1 newtons. So now we've got our R, and we can proceed to the next part of the question, where we need to find the angle that it makes with OX. In the next part, since we have a triangle that looks like that, and we have this angle here that we're interested in, let's call that angle A, and we have this side here, which is 12, let's call it little a, and we have this one, which is 60, and we just calculated this one, which is 11.1. Then we have opposite angle and side, and then opposite angle and side. So we're going to use the rule of sines to solve that one, and that should be quite simple to visualize. So that would be sine of the angle that I want, which is A, divided by little a, which is 12, this 12 here, is equal to the sine of 60 divided by 11.1. But let's use the whole of the answer, so that would be root of 124. So then we would multiply by 12 both sides, and then we would do shift of A, and we would get the answer. Hopefully you can do that on your own, and in the next video I'll go on to the next question, because it's a bit silly just to finish that off. That should be, it's the same as I did in the last video. Alright, thanks for listening. See you in the next video.